Hello, welcome back. Back to this other channel. Since YouTube revoked my permission to stream, I am back now. And should not go across that problem again. Anyways, time to get on the mission topic. Today is AIS baby. That's a weird way to put it, but to me like it works. The launch time is Sunday, November 24th, 2024 at 9:55 p.m. CST. And this time is for 4:55 p.m. CST, so it will be launching at day or around sunset. Um, this is Electron slash Curie. This is the Kind CS 11 slash 15 Pro or satellite. There's gonna be 5 of these on board. The total mass of it will be 150 kg. It'll be going to low Earth orbit, and this mission will be launched from LC-1B Maha Peninsula, New Zealand. This will be a 222nd orbital launch attempt of 2024, the 56th mission for RocketLab. Overall, it will be the 14th mission of 2024. This will be the 56th overall mission for Electron. It will be the 14th mission for Electron this year, which is impressive. Thinking that they launched only about 10 to under like maybe like 9 times last year. But whew. Hold up. Yep, that's it. We're just waiting on Electron to start the stream. Stream now. I'll be waiting here in the background just in case. Just let me tell you, I deleted my live channel. I just want to progress onto this channel. I don't want to like work with any other channel. I just want one main channel to either put lives on or make videos. Also, big announcement: Starship Flight 5. Yeah, I predicted that would launch in December and January. That's what I predicted. And I said it would launch on the weekend. Guess what? guess guess what? Guess what? Is gonna launch. It's gonna launch on January 11th on Saturday. We gonna get to stream it for a fourth time. I got to stream flight 4, 5, 6, and now maybe 7. I mean, like, what could I say? Alright.
This is the story of
Alright, y'all. Enjoy the launch, y'all.
4:37 p.m. overlooking Launch Complex 1 in Mahia on New Zealand's eastern shore. It's launch day for the AIS Baby mission. You're looking at live views of our Electron rocket on the pad as we get ready to go to space at 4:55 p.m. local time or 3:55 UTC. My name's James Rattray and I'm the Senior Video Content Producer here at RocketLab, and I'll be sharing today's launch updates with you live from Mission Control along with Sam. Thanks so much for joining us, Sam.
Thanks for having me. Today's mission is our 56th launch overall and our 14th mission for the year. Our previous annual launch record was 10 missions last year, so we are flying well past that in 2024 with another month still to go.
So what's going to orbit today? Well, tucked inside Electron's fairing are 5 satellites for French Internet of Things constellation operator Kinéis. This is the third of 5 dedicated missions for Kinéis, booked on Electron as part of a multi-launch contract that will see us deploy their entire constellation of 25 satellites. By flying as the dedicated customer on Electron, Kinéis doesn't have to share their ride with other satellite operators, and that puts them in the driver's seat of their mission when it comes to launch schedule, orbit, integration operations, and even launch site.
That's right. Today's launch is our 56th launch, but our third for Kinéis. We've launched 2 other missions for them this year, one in June and another in September. Both of these missions deployed 5 satellites each, and that's the same configuration within Electron's payload today. Each of these satellites will be deployed to a unique orbit by Electron's kick stage at an altitude of around 640 kilometers and an inclination of 97 degrees. After today's launch, we have another 2 on the books for Kinéis, totaling 5 launches, all up to deploy the complete constellation of 25 satellites. With these 25 satellites, Kinéis will provide Internet of Things connectivity, essentially connecting any object from anywhere in the world and transmitting useful data from these objects to users in near real time. What this looks like in practice is sensors on the ground monitoring things like forest fires, floods, pollution levels, agriculture, wildlife movements, maritime activity, and more. These sensors are connected to the internet via Kinéis' satellites, meaning they can transmit vital information and changes to help people and organizations respond faster and understand more. Let's hear more about it from the team at Kinéis.
Kinéis is a French company based in Toulouse. We are a satellite operator and a global connectivity provider dedicated to the Internet of Things. Mountains, ocean, deserts. 85% of our planet has no network coverage. In 2020, we raised a large amount of 100 million euros to address this global issue. Today, we are following through and will deploy a constellation of 25 nanosatellites that will enable us to connect to a multitude of objects anywhere on the planet in near real time. We are convinced that this transmission of information made possible by satellite connectivity will enable us to respond to crucial challenges for mankind, its activities, and its environment. On the environmental front, for example, Kinéis connectivity can detect a fire outbreak in less than 15 minutes, thus considerably reducing the extent of the outbreak and reducing the loss of property and human life. The same goes for monitoring water levels to prevent flooding and use this dwindling resource. The applications are endless, whether for locating, monitoring, or alerting. Since the creation of Kinéis in 2018, our teams have been working with this objective in mind. Our 25 nanosatellites that weigh only 28 kilograms are real technological gems. The retractable UHF antenna, for example, can hear a bird sing within a rock concert 650 kilometers from the Earth. We fitted them with thrusters to ensure they stay on track for their mission. Some even carry children's drawings. That's amazing. At the same time, we have deployed many ground stations worldwide and have a sovereign infrastructure to guarantee data transmission to our clients. We currently have 10 satellites orbiting the Earth, and RocketLab is preparing our 3rd launch today, bringing our constellation to 15 satellites out of 25. Each added satellite reinforces our global network, offering a unique IoT connectivity to meet our planet's growing needs. We cannot wait to see this constellation grow.
We only have about 13 minutes to wait until the next 5 Kinéis satellites are on their way to space to continue building out this growing constellation.
But before we take a closer look at those satellites and how they'll make their way to orbit in just over 12 minutes, let's check in with the operators in mission control to hear the go, no-go poll for today's liftoff. Right now, operators are on console in two places, mission control here at our production complex and in range control at the launch site. You can see both of them on your screen there, and that sits about 3 kilometres back from the pad. So let's listen in to hear what those operators have to say about the status of today's launch, led by Launch Director Paula Tares-Serralonga.
To all stations proceeding with go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
Med is go.
MM.
MM is go.
LDSUP.
LDSUP is go.
Go, no-go sequence complete. We are T-minus 11 minutes 25 seconds and counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
That's what we want to hear. Greens across the board from the launch operations team. That confirms we are go for launch in around 11 minutes. Now, today's mission requires an instantaneous launch to deploy the Kinéis satellites to a precise orbit. That means we have exactly one opportunity for launch today. That is 4:55 p.m. local time here in New Zealand and a bright and early 4:55 a.m. for the Kinéis team and rocket fans in France.
Today's launch might be number 3 for Kinéis, but it's 56 overall for Electron and our 14th launch this year. It follows hot on the heels of our most recent launch just 22 hours ago, less than a day from Launch Complex 2 in Virginia. The pad and ops teams have been putting in the work to launch 2 rockets from 2 pads on 2 continents in 24 hours.
So if you want to join the team launching and relaunching or working on Electron, Neutron or our space systems programs, chances are there is a place for you at RocketLab right now. If you've ever wondered what being part of our team looks like, here's a sneak peek.
If you walk into any of RocketLab's facilities, the first thing you'll read is "We go to space to improve life on Earth." And that's really the foundation of the entire mission of RocketLab. So the way to think about RocketLab is we're not just a launch company, not just a spacecraft company, we are an end-to-end space company. And I think what sets RocketLab apart is you actually get to build hardware that goes to space. And not just go to space, but go to Mars, go to the moon. You're never like a little gear in a giant machine. You get given huge responsibilities within the company. If you come to work at RocketLab, you can expect to build beautiful things that work beautifully. Don't expect 9 to 5, but do expect to have an actual meaningful impact on the world.
I love working here. If that looks like a good day at work to you, it sure does to me. Visit our website to apply today. All right, we have just 6 minutes and 21 seconds left on the countdown clock, so let's walk through what to expect from today's flight. As we hit T0, the 9 3D printed Rutherford engines on Electron's first stage will ignite to propel the vehicle off the pad. Those engines will burn through the liquid oxygen and kerosene in Electron's first stage tanks for about 2.5 minutes until Electron reaches the edge of space at around 80 kilometers in altitude. It's at this point the 9 Rutherford engines will shut down in preparation for stage separation between Electron's first and second stages. Then within seconds, the vacuum-optimized Rutherford engine on the second stage will ignite and propel Electron for around another 6.5 minutes all the way to an elliptical transfer orbit. In those 6.5 minutes, Electron will reach speeds of around 27,000 kilometers an hour to hit orbital velocity, and from this point on, it's all up to the kick stage.
That's right, the kick stage is the ace up our sleeve. It is responsible for our pinpoint payload deployment accuracy. It will separate from Electron's second stage, carrying all 5 satellites for Kinéis, and coast in an elliptical orbit for around 50 minutes. After this, the Curie engine ignites to circularize the orbit and deploy the satellites to their final orbits at 643 kilometers altitude. We have one final maneuver after deployment, though, which is a kick stage perigee lowering burn. This will help reduce the stage's orbital lifetime as part of our effort to keep space sustainable.
Before all that, though, at the T-2 minute mark, Electron's flight computer will take over the countdown and autonomously run us through our final operations. Liquid oxygen will continue to flow into Electron all the way up until T-1 minute and 30 seconds, and then Electron's first and second stages will be fully pressurized and ready for launch. Now that you know what to expect, let's watch it all happen live. We'll throw it back to the team in mission control for that final pre-launch sequence.
LD, GC on mission code.
GCLD.
LD, the ECS is disabled. Pad auto sequence has been armed. The pad is ready for launch.
Thank you, GC. From now, there should be no red flags on your critical LCCs. Beacon LD mission code.
LD Beacon.
Beacon, log the auto sequence and confirm.
Auto sequence locked.
And confirm all expected primary flight computer ASCOs are green.
All ASCOs are green.
We'll go for auto sequence start at T-2 minutes. LDs go for launch.
the vehicle is fully on internal power. AFTS is green enable for flight.
LOX load is complete. The system is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over.
Stage 1
And there you
propulsion
have
nominal.
it, 22 hours after the last one, we're off the pad again for Ice Ice Baby. Now that it's cleared the pad, Electron will soon approach max Q, or maximum aerodynamic pressure, and that's the moment in flight when Electron experiences peak structural load. We'll hear that call out from GNC team in mission control shortly, so let's keep an ear out.
Vehicle is supersonic, approaching max Q. Cleared. Discharge nominal. Cleared max Q.
That's what we like to hear. Electron has successfully sailed through max Q. We are now at 17 kilometers in altitude and traveling at over 2,500 kilometers an hour. Up next, in quick succession, we will see main engine cutoff called MECO, stage separation, and then stage 2 engine ignition. All three events take place within seconds, so it's a busy and complex point in
Guidance
flight.
is nominal.
Having completed their role in the mission, all 9 of Electron's Rutherford engines will shut down to prepare for stage separation. Once free from stage 1, stage 2's single Rutherford engine will ignite to power Electron the rest of the way to orbit. Let's listen in for those calls.
In 30 seconds.
$15 seconds to staging.
Enter burnout detect mode.
MECO confirmed.
Stage separation successful.
Nice.
Stage 2 ignition confirmed.
That's 3 for 3 successful MECO, stage separation, and second stage ignition confirmed. You can see at the top right of your screen there that Electron is moving at 8,170 kilometers an hour, now passing just under 100 kilometers in altitude.
Now that we are well and truly in space, we no longer need the fairings which protected the Kinéis satellites from these intense conditions as it traveled through Earth's lower atmosphere. The operators in mission control will make the call for fairing jettison soon. And that there was the call out for fairing jettison from mission control. With just 6 minutes remaining in the second stage burn, we are at an altitude of 123 kilometers and about halfway through today's flight.
We're getting some splendid views there of the second stage from the second stage camera, with its Rutherford engine propelling us past 9,800 kilometers an hour. Now, this Rutherford engine is the same as the 9 on stage 1, except for that nozzle that you can see glowing bright. That nozzle extension allows for the combustion gas to expand to a higher velocity before leaving the engine, and velocity equals thrust. All of that to say that it gives us a much more efficient ride to orbit.
Stage 2 propulsion nominal.
Electron's second stage engine continues to burn nominally as we make our way to space on our 56th launch. The Rutherford engine is unique in that its fuel pumps are powered by batteries rather than a traditional gas turbine. This allows us to extract high performance from the engine and control throttling. Once we deplete the power in the first set of batteries, there's no need to carry this dead weight for the rest of the mission. So we jettison them and swap to a fresh set for the rest of the journey. It is a maneuver we have fittingly called battery hot swap, and it's up next. So keep an eye on your screen to see the shiny silver batteries eject and fall away. But watch closely, because if you blink, you'll miss it. Let's listen in for the call.
AGB discharge nominal, approaching hot swap in roughly 30 seconds.
Guidance is nominal.
Battery jettison confirmed.
Hot swap successful.
Battery hot swap successful. That fresh battery pack is now helping to power Rutherford the rest of the way to orbit. There is just one milestone remaining before the kick stage separates, ready for payload deployment, and that is SECO, or second engine cutoff. The final engine cutoff is coming up at just over 9 minutes into the mission.
FTS has saved.
All right, T plus 7 minutes into the flight, and Electron's second stage is performing nominally. Just a few minutes to go until SECO and kick stage separation, and we'll go into a little bit more detail on that a little closer to the milestone. Then it'll be about 45 minutes until we get to the business end of launch, and that's payload deployment. If you've seen one of our previous launches for Kinéis, you'll have no doubt seen the nifty maneuvers we'll do with the kick stage to deploy their satellites into the optimal location. Using our cold gas RCS, or reaction control system, we can rotate, flip, and reorient the kick stage along the same path for precise payload insertion.
Stage 2 propulsion holding nominal.
Just under a minute left in the second stage burn. We're getting close to orbit there, exceeding speeds of 23,000 kilometres an hour and at an altitude of 205 kilometres. When you hear the call out, entered burnout detect mode from our mission control operators, you know SECO is coming up close. It means the engine is throttling down in preparation for shutdown, officially completing Electron's journey to orbit in preparation for kick stage separation. You'll hear that call soon, so let's check back in with the team in mission control.
SECO confirmed.
Stage 3 separation confirmed.
And there we have it. Electron is in a transfer orbit as planned, and the second stage engine has shut down successfully. The kick stage carrying all 5 Kinase payloads has also separated and is entering the coast phase for around 45 minutes. Once at apogee, the kick stage's 3D printed Curie engine will ignite and complete the final leg of the mission. That is, kick stage circularization and payload deployment to 643 kilometers altitude.
The satellites on today's mission will be deployed in a precise order. First, a single satellite will be deployed off the top of the kick stage, followed by the remaining 4 satellites deployed in pairs from opposite sides of the kick stage. That final phase of the mission is scheduled to take place at around 45 minutes or so from now, so we're going to take a short break while the kick stage circles the globe. We'll leave you with a graphic of where the kick stage is above the Earth and the chill tunes of our good friend, the everyday astronaut. We'll be back with you soon for payload deployment.